welcome once again to my YouTube chemistry channel. I hope you guys are doing well at your home and you all stay happy, healthy and safe. So this is my second video of topic atomic structure for class 11th chemistry. So let's start today. So in this video we are going to discuss about some more topics of atomic structure. First is discovery of protons and neutrons. So electrical discharge carried out in the modified cathode ray, and it led to the discovery of particles carrying the positive charge. So through this experiment, scientists were able to find out the new particle, that is positively charged particles called proton, which was initially known as canal rays. So the positively charged particles depend upon the nature of gas present in the cathode ray tube. So these are simply the positive charge gaseous sign. The charge to the mass ratio of the particle is found to depend on the gas from which these originate. So basically the charge to the mass ratio, it depends on the quality of gas and the nature of the gas which is present in the cathode ray tube. And some of the positively charged particles carry a multiple of the fundamental unit of electrical charge. So the behavior of these particles in the magnetic or in the electric field is opposite to each other. To that observed for the electrons or cathode rays, the smallest and the lightest positive ions was obtained from the hydrogen, and which was known as proton. So basically the positive ions which are smallest and the lightest it was obtained from the hydrogen, so it was known as proton. The scientist Eugen Goldstein in 1886, he was the one who observed what is now called the proton particles with a positive charge and the relatively mass of 1. As we all know, nowadays we are using for the proton that it is having atomic mass of 1. 1h1 we are writing, or 1840 times that of electron. So in 1932, a new scientist, James Chadwick. So all these names of the scientists are very important, and gradually what were the research experiments which was done by these scientists, how they conclude the presence of particles, that is positively charged particles. So these names are very important. You guys have to write down in your notes, and these slides are very important बच्चा. So आप लोग please ध्यान से सुनिए whatever I'm going to dictate and read for you these slides. You guys can take a snapshot also. So in 1932, James Chadwick ने confirm किया the existence of neutron. So first particle that was invented, or that was the experiment was done, was J.J. Thompson, and who invented electron particles, negatively charged particle. After that, the proton, which was done by Goldstein in 1886, and later on in 1932, James Chadwick, he confirmed the existence of neutron, a particle with no charge but a mass nearly equal to proton. So this is the summarized way: subatomic particles, that is electron, proton and neutron, and the absolute charge on electron, as I already told in my previous video, in the first video, minus 1.602 10 to the power minus 19, and the relative charge is minus 1, and the mass is 9.11 into 10 to the power minus 28. Next one is the proton. Absolute charge is 1.602 10 to the power minus 19. Relative charge is plus 1, and the mass is 1.673 10 to the power minus 24. And the last one is neutron. It is electrically neutral, so it has no charge, and the mass is 1.675 into 10 to the power minus 24. Now we are going to discuss about the atomic models. These models are very important for your basics. Thompson atomic model was the first who he has given the atomic model. So what he has given, that pudding. So there's a pudding. There's a pudding. Thompson believed that the electrons were like plums, which is embedded in a positively charged pudding. Thus it is called the plum pudding model. J.J. Thompson in 1898 he proposed that an atom possesses a spherical shape, radius of atomic 10 to the power minus 10 meter, in which the positive charge is uniformly distributed. The electrons are embedded into it in such a manner as to give the most stable electrostatic arrangement. So this model considered that the mass of the atom is assumed to be uniformly distributed over the atom. Okay, although this model was not able, or actually it was able to explain the overall neutrality of the atom, and it could not explain any other properties. So basically what J.J. Thomson was told, that there is a plum over which there is a negative particles. Okay, so he has proposed this spherical shaped structure of an atom in which a positive charge is uniformly distributed and the electrons are embedded. Positive charge पूरे में throughout the sphere यूनिफॉर्म डिस्ट्रीब्यूशन था, और इलेक्ट्रॉन्स इसमें स्मॉल स्मॉल इलेक्ट्रॉन्स एम्बेडेड थे जैसे कि प्लम्स में होते हैं. एंड देन इसने जो सेकंड पॉइंट बोला था, दैट द मॉडल कंसीडर्ड मास ऑफ द एटम इज एज्यूम टू बी यूनिफॉर्मली डिस्ट्रीब्यूटेड. जो ओवरऑल मास ऑफ द एटम था वो यूनिफॉर्मली डिस्ट्रीब्यूटेड था, एंड एज पर दिस मॉडल ही वॉज एबल टू एक्सप्लेन द ओवरऑल न्यूट्रलिटी, कि ओवरऑल जो एटम होता है वो न्यूट्रल होता है, but he could not be able to explain any other property of the atom. Later on, Ernest Rutherford, he carried out an experiment through gold foil experiment. It was known as gold foil experiment, and in 1911 he performed this experiment, in which what happened, he has emitted alpha particles which will attack on the gold foil, and there is a detecting screen also. So these alpha particles are helium nuclei. The alpha particles were fired at a thin sheet of gold foil, and the particles that hit on the detecting screen are recorded. So what Rutherford finding was, most of the particles passed right through a few. What happened in this? The alpha particles go straight. A few particles were deflected, whereas a very few were greatly deflected. Okay. So in this, what happened? Most of the particles go straight. Some of them get deflected. So what he has concluded, that he concluded that nucleus is very small and the nucleus is very dense, and the nucleus is having the positively charged particles. So the Rutherford atomic model, it was based on his experiment evidence that the atom is mostly empty space, and all the positive charges, almost all the mass is concentrated into a small area in the center. So most of the positive charge is there at the center of the nucleus, and he called this as a nucleus, and the size of the nucleus is very very small. So these are the postulates and the conclusion given by Rutherford atomic model. And the other points were that the positive charge and most of the mass of the atom is concentrated in the extremely small area which is called nucleus, and the nucleus is surrounded by electrons. So overall neutrality, he has discussed about that the nucleus is surrounded by the electrons that move around the nucleus with a very high speed in a circular path called orbits. So 2 points which he has given, first is that the nucleus concentrated mass is there which is having the positive charge, and that concentrated mass he named it as nucleus, and there are orbits also in which electrons are moving at a very high speed, and electrons in the nucleus are held together by electrostatic force of attraction. What was the drawback of the Rutherford model? When an electron is moving in an orbit, it undergoes acceleration. बच्चों क्या होता है, जब भी कोई चार्ज पार्टिकल किसी सर्टेन वेलोसिटी के साथ एक्सेलरेट करता है या किसी ऑर्बिट में मूव करता है, so it undergoes an acceleration because of changing direction. So according to the electromagnetic theory of Maxwell, charged particles when accelerated should emit electromagnetic radiations. कोई भी charged particle जब किसी orbital में move करता है at a very high speed, because of which what happens, there is a formation of electromagnetic radiation. So what happens, therefore an electron in an orbit will emit some radiations, and as a result the radius of orbit will continue to shrink, because of which what happens, जो orbit है हमारे nucleus के surrounding में वो shrink होता रहता है, and this may lead to the falling of electron to the nucleus. और अगर वो shrink होगा, जो electrons जो move कर रहे हैं orbit में, it will drop down to the positively charged nucleus. But it does not happen, but practically actually it does not happen. So this is one of the major drawback of the Rutherford of this model. This is one of the major drawback of the Rutherford model, and it cannot explain the stability of an atom. So this model was failed to explain the arrangement of the electron around the nucleus. उन्होंने ये तो बताया that there are certain positive charge concentrated in the nucleus and there are orbits, और उस orbits में क्या होता है, electrons move करते हैं which are negatively charged, but he was not able to explain the overall neutrality, and he said these are charged particles, और charged particles जब किसी ऑर्बिट में मूव करते हैं, because of which there is an electromagnetic radiation, so it results in the formation of shrinking. So now talking about the atomic number, So atomic number of an element is the number of protons in the nucleus of each atom. So atomic number is equal to number of protons, which is equal to number of electron. Also here I have written carbon, phosphorus and gold. Carbon, we know the atomic number is 6, phosphorus is 15 and the gold is 79. So the number of protons will be equal to the number of atomic number, and mass number is equal to number of protons plus number of neutron is equal to mass. So here I have written the formula also. The mass number is the sum of proton and neutron in the nucleus of an isotope. Here I have discussed about the few elements, that is your oxygen, arsenic and phosphorus. Number of proton is 8, number of neutron is 10 and the number of electrons is 8. I am talking about the oxygen element. So overall mass is equal to 18. Now talking about the arsenic, here the number of proton is 33, number of neutron is 42 and the atomic mass is 75. Similarly, if we talk about phosphorus, number of proton is 15, number of neutron is 16. So as the number of protons and electrons are equal, so it would be 15 and the mass is 31. Now talking about the complete symbols of an element, how we represent an element through a symbol. So it contains the symbol of the element which is having the mass number and the atomic number. Mass number is always at the superscript and the atomic number will always be at the subscript. Now about isotopes, Dalton was wrong about all the elements of the same time being identical. He was wrong actually, and what he has given and the statement given by him was that the atom of same element can have different number of neutrons, thus different mass number. तो क्या बताया था उन्होंने कि एटम्स जो सेम एलिमेंट के एटम्स है कैन हैव डिफरेंट नंबर ऑफ न्यूट्रॉन्स, और अगर डिफरेंट नंबर ऑफ न्यूट्रॉन्स होंगे तो मास नंबर भी अलग होगा, जबकि ये गलत था. So these are called isotopes. Okay. Now in 1877 to 1956, a new scientist, Frederick Soddy proposed the idea of isotopes in 1912. In 1912, he proposed the idea of isotope, and the statement given by him that isotopes are the atoms of the same element having different masses due to varying number of neutrons. क्योंकि नंबर ऑफ न्यूट्रॉन्स डिफरेंट होंगे तो हमारा मास नंबर डिफरेंट होगा. तो आइसोटोप्स के बारे में उन्होंने क्या बताया, आइसोटोप्स आर दोज विच आर हैविंग डिफरेंट मास नंबर. एंड सोडी he won the Nobel Prize in Chemistry in 1921 for his work with isotopes and radioactive materials. So different isotopes are the atoms of the same element having different masses due to varying in the number of neutrons. Here you guys can see hydrogen. The example given is hydrogen, which is having atomic number that is 1, but they are having the different number of neutrons, so total atomic mass will be different of these three. हाइड्रोजन के हमारे 3 आइसोटोप्स जो हम लोगों को पता है, H1, H2 and H3, and their atomic mass is different because they are having the different number of neutrons. Now talking about element occurring in the nature as mixture of isotopes. जैसे कि आप लोग यहाँ देख रहे होंगे, if I talk about hydrogen, it is having 3 different isotopes. Similarly, helium is having 2 protons and number of atomic mass is 3 and 4. Similarly, if we talk about lithium, it is having 3 protons with atomic mass 6 and 7. So isotopes are the atoms of the same element that differ in the number of neutrons. Now what are isotopes and what are isobars? How can we differentiate? Isobars are the atoms with same mass number but different atomic number. So they are having the different atomic number but their mass will remain same. For example, carbon 14 and 14 nitrogen. On the other hand, atoms with the identical atomic number but different atomic mass are known as isotopes. So this is a very important slide because the definition has been given for isobars and isotopes. Normally students get confused about the definition of isotopes and isobars. So any mnemonics you can learn in isotope, you always remember it is because of the different mass number and the same atomic number. Isotopes में atomic number same होते हैं, mass number different होता है. जबकि isobars की हम बात करेंगे, they are having the same mass number but different atomic number. So isotopes are having the same chemical properties but different chemical properties. They are having the same chemical properties because they are having the same number of protons and electrons, and that too their atomic number is also same. That is why isotopes are having the same chemical properties but different physical properties. Now talking about development leading to the Bohr's model, उसके बाद जो साइंटिस्ट है दैट इज बोहर, उन्होंने एक अपना मॉडल दिया दैट इज द बोहर्स मॉडल ऑफ एटम, एंड ही हैज गिवन few postulates and few statements, and what he has given that the dual characteristic of electromagnetic radiations and experimental data regarding the atomic spectra. So what he has given the dual character of electromagnetic radiation, that is wave nature and the particle nature of the electromagnetic radiation. Very important points of the Bohr's model of atom, that is particles are wave in nature, electromagnetic radiations are wave in nature and that too in particle in nature. Electromagnetic radiation के बारे में इन्होंने dual character बताया था, and the wave nature of electromagnetic radiation as per James Maxwell in 1870 he suggested that when electrically charged particle is accelerated, alternating electrical current or magnetic field are produced and transmitted. So these fields are transmitted in the form of waves and which are called as electromagnetic waves or electromagnetic radiation. जब charged particle accelerate होते हैं तो alternating magnetic current, magnetic field generate होता है या electric field produce करते हैं जब भी कोई charged particle किसी orbit में move करते हैं, और जो ये fields हैं these fields are transmitted in the form of waves, और ये किस में transmit हो जाते हैं waves में, जिनको कि उन्होंने क्या डेफिनेशन दिया, दीज आर नोन एज इलेक्ट्रिक मैग्नेटिक वेव्स और इलेक्ट्रोमैग्नेटिक रेडिएशंस। और कुछ उन्होंने पॉइंट्स बताए थे, ये इंपॉर्टेंट पॉइंट्स है that the electric and magnetic fields are perpendicular to each other and both are perpendicular to the direction of propagation of the wave. ओके ये दोनों एक दूसरे के परपेंडिकुलर होते हैं, प्लस ये दोनों ही परपेंडिकुलर होते हैं डायरेक्शन ऑफ प्रोपोगेशन के। इलेक्ट्रोमैग्नेटिक वेव्स डू नॉट रिक्वायर एनी मीडियम, कैन मूव इन वैक्यूम, इनके लिए किसी मीडियम की जरूरत नहीं होती, अगर एम्प्टी वैक्यूम ट्यूब भी है तो उसमें भी इलेक्ट्रोमैग्नेटिक रेडिएशन मूव करते हैं। दे डिफर फ्रॉम वन इन वेवलेंथ, इनके वेवलेंथ डिफरेंट होती है, लैम्डा डिफरेंट होता है। दे ट्रेवल एट द स्पीड ऑफ लाइट एंड द फ्रीक्वेंसी ऑफ वेवलेंथ that is v is equal to n lambda हम लोग बोलते हैं, where n is frequency, lambda is wavelength and v is velocity, or we can say c is velocity. Here this is the range of visible range, infrared range, microwave, electromagnetic radiations का पूरा इसमें चार्ट दिया हुआ है बच्चों। You guys can see the different radiations having different wavelengths, इसमें हम कैसे कैसे electromagnetic radiations को different categories में डिफ्रेंशिएट करते हैं, दैट इज गामा रेज, एक्स रेज, यूवी रेज, विजिबल रेंज हमारा कहाँ से कहाँ तक है, देन योर आईआर, माइक्रोवेव एंड रेडियो फ्रीक्वेंसी। नाउ टॉकिंग अबाउट द पार्टिकल नेचर, फर्स्ट हमने वेव नेचर के बारे में पढ़ा, इलेक्ट्रोमैग्नेटिक रेडिएशन। नाउ टॉकिंग अबाउट द पार्टिकल नेचर ऑफ इलेक्ट्रोमैग्नेटिक रेडिएशन, so diffraction interference could also be explained by the wave nature of the radiation, but they could not explain, उन्होंने वेव नेचर के बारे में तो बताया बट नॉट एबल टू डिस्क्राइब अबाउट द ब्लैक बॉडी रेडिएशन, फोटोइलेक्ट्रिक इफेक्ट, वेरिएशन ऑफ हीट कैपेसिटीज ऑफ सॉलिड एज फंक्शन ऑफ टेम्परेचर इन द लाइन स्पेक्ट्रा। So the first concrete explanation for the phenomena of the black body radiation was given by, or it was done by Max Planck in 1900. When an iron rod is heated, it turns to dull red and then becomes more and more red. As this is heated, further the radiation emitted becomes white and then become blue as the temperature becomes very high. किसी रॉड को उन्होंने हीट अप किया था वेरी हाई टेम्परेचर, तो उससे क्या हुआ, रेडिएशन मूव आउट हुई, एंड फ्रीक्वेंसी ऑफ द रेडिएशन एमिटेड गोज फ्रॉम अ लोअर फ्रीक्वेंसी to a higher frequency as the temperature increases. So the ideal body which emits and absorbs all the frequencies is known as black body. So this is the definition of a black body which actually emits and absorbs all color and all frequency lights, and the radiation emitted by such body is called black body radiation. So बच्चों this is the end of the second video. I hope आप लोगों ने first video भी देखा होगा, इसमें हम लोगों ने बहुत सारे मॉडल्स पढ़े, रदरफोर्ड मॉडल्स के बारे में पढ़ा, इसमें हमने बोहर्स मॉडल के बारे में पढ़ा, इसमें हमने वेव नेचर एंड पार्टिकल नेचर ऑफ इलेक्ट्रोमैग्नेटिक रेडिएशंस के बारे में पढ़ा, ड्रॉबैक क्या थे हमारे रदरफोर्ड मॉडल में वो भी हमने डिस्कस किया है। आई होप आप लोगों को ये वीडियो पसंद आई होगी, एंड इन केस इफ यू फील लाइक दैट दिस वीडियो इज एक्चुअली यूजफुल फॉर यू and it will actually enhance your knowledge, do like, share and subscribe my channel. Thank you.